Welcome to this week's MTD podcast. In this podcast, we will be discussing ways to reduce cost per part on high mix, low volume work. I'm Giovanni Albanese, hosting today's show, a passionate engineer and a proud member of the MTD team. Today, I have the pleasure to be joined by three special guests. Firstly, Llyod Cooper, an advocate for technology and plant manager for Parker Hannifin in Sheffield, of Instrumentation Products Division Europe, a passionate engineer with a strong, innovative business approach. Welcome, Llyod.
Welcome. Thank you very much for having me on. It's a real big pleasure. So really excited to get into discussing some of the stuff today.
Now, brilliant to have you, Llyod. And secondly, we also have the pleasure to be joined by your colleague and partner in crime, James Utting. 18 years in engineering so far. He started at the age of 17 as an apprentice in precision tool making for the automotive industry, and quickly got involved with CNC milling, programming, and after completing his apprenticeship went on to other roles in the oil and gas, nuclear and defence industry, and now a senior production engineer at Parker Hannifin, Sheffield. Welcome, James.
Thanks, Gio. It's a pleasure to be here.
Brilliant to have you as well, James, and look forward to getting into this podcast. And finally today, a good friend of mine for over 10 years now. We met from bumping into each other at large OEM companies over the years on a weekly basis. An industry leader for sure, and a very liked and well-known face within the industry, helping OEMs and end users alike. A work-holding master, Nick Peter, the Managing Director of Hainbuch UK. Welcome, Nick.
Thanks very much, Jake. I'm really impressed with that. Thanks
very much. Well, it's great to have you all on this podcast, on this MTD podcast. It's an absolute pleasure for MTD. This all stemmed about from our visit to your facility in Sheffield last week, James and Llyod. And it was an absolute pleasure for us to kind of see the kind of work that you're doing, the investments and technology that you're investing in. Firstly, and before we move into that, can you all just give me a very brief overview, really, of kind of what got you into engineering, what you like most about engineering, and about the businesses that you work for respectively? And I'll start with you, Llyod, if that's okay.
So really, it's a bit of a family affair. My dad's a senior mechanical engineer, so before I could really articulate words, he was showing me drawings. My dad came up with the design engineering route. I think on the first ever CAD packages when I was a young kid, I was learning to draw squares and extrude circles and things like that. So I've always been heavily exposed to engineering and really, getting involved with the understanding and the applications of stuff. And that really manifested itself growing up, building things. I was very much into bikes. I was welding my own bike frames together at like 14 and 15. My first job was in one of the places my dad worked was in a little CNC turning shop. At first just sweeping up and cleaning the swap out the bottoms of the lathes and stuff. And it developed a little bit, getting on the manuals and just turning simple components. So really, I've been exposed to engineering throughout my entire life, and it's just grown and grown and grown, really. From a business perspective, so I did similar route to my father. At university, I've done mechanical design engineering, so really heavy in obviously component, FEA analysis, things like that. After uni, I've gone into, I did a couple of years of project engineering, more like structural steelwork, platforms and structures. But then I made after that the jump into operations. So quite two diverse businesses I've worked in. The first was an aerospace company looking at like siliconized seals. So quite unlike most typical engineering firms with more polymers. And then coming towards Parker, which is cryogenic valves, so chalk and cheese in terms of product applications. But, I think from a personal development point of view, having a solid engineering grounding has served me so well in my ability to manage operations within any business, And I think you look at a lot of senior leaders, and they've got very representative backgrounds in engineering. So I think it's been a fortunate thing that's what I was into from a young age.
Yeah, well, it's sounds like it's in your blood, Llyod, and I think that come across. When we come to meet you at your facility last week, I mean, the passion comes out, and the innovation and the technology side of your kind of business strategy is something that we'd like to touch on a bit more later in this podcast. So thanks for that, Llyod. Now, James, can I ask you the same question, please? What do you like most about engineering, and how are you finding it at Parker Hannifin?
Firstly, the main thing that I enjoy about engineering is just that satisfaction that you get when you've actually created something. Although it's a very sort of technical industry, if you're a creative person, it's a fantastic career. Because a lot of the time you do have to sort of think outside the box when you come to solve a problem, and that's where that sort of creativity can be put to good use. I'm really, really enjoying my time at Parker Hannifin. I've been very lucky in my career so far that I've worked for some good companies with fantastic support from the management and other people that I've been working with, and it's much the same in Parker Hannifin. They really do like to foster the talent, look after the talent, and create an environment where you can grow and develop yourself. That's one of the big takeaways that I get from working at Parker.
Brilliant. And I think that education is key by the sounds of it, James. And I think that, again, it was a pleasure to meet you last week. And I look forward to discussing the automated project that we were looking at. And Nick, what about you, mate?
Yeah, I mean, much the same as Llyod, really, to be honest. I've got a granddad that was an electrical engineer, a very hands-on, practical guy. Would give me things, bring things home from work when I was quite little and put them on a tray, a little electrical switch box, and said, there you are, take that apart. I'll give you £1 if you manage to put it all back together again the next week. So from a very early age, you get used to taking things a bit to bits, putting them back together again. And that fosters a sort of want to learn and find out how things work. My dad was also an engineer, and again, like Llyod, I used to go and sweep the floor on a Saturday morning while he got me a sausage sandwich. So that's a quite nice introduction to things. But yeah, it was pretty obvious then that I was going to go on to be an apprentice, and a mechanical engineering apprentice, which I did, which was a great thing to do, to be honest. And apprenticeships, I think, are very undervalued because I got to work in all departments, drawing office, workshop floor, everything at all. So you meet some fantastic old guys who can teach you an awful lot of stuff. And that sort of stuff that you learn when you're sort of 17, 18, 19 really stands you in good stead all the way through. So I'm still learning now. Engineering is one of those things that you never are an expert in. You're always learning. But just keep going. It's a wonderful job to have. As my dad said when he gave me the engineering apprenticeship, he said, you'll have a job for life. And he was absolutely right.
Yeah, I think that's some really good points there, Nick. I think you never stop learning because technology is just evolving at such a fast rate. It's hard to keep up with it at times. And going back to kind of what you said about, going back to like you guys, the ground roots from when you were kids and your grandfathers and fathers, my children, they love trains at the minute. They love cars at the minute. It's the perfect time to kind of get them learning about engineering. I don't know what happens to them while they're at school, but they seem to lose it and come out of school not as interested in it sometimes. And I think that there's definitely something there that whilst they're at school, that there needs to be more of an emphasis from then. And the apprenticeship thing where you're actually making components and learning how to make components, having a feel for it, is absolutely imperative because you can't design anything unless you know how to make it, or else you're kind of just completely over-engineering or potentially over-engineering components. Llyod, you've got something to say about this?
I still think we might make that mistake. As a funny little anecdote, I remember my first week in industry after university. We were designing this aluminium lifting platform, and I still think, as much as of a good engineering background, I remember putting a clearance hole in something for a bolt, and it worked in the CAD model. And I remember some big hairy on-site engineer busting in the office and going, "How am I going to get my span around that son?"
But it's so true. Like when I was in the aerospace industry, we used to manufacture. Well, I used to work on a cell called Strangers and Aliens. So any new components for the engines used to come through this cell before we. So we proved them out. We create the fixturing jigs. And once we got them passed off, they'd move on to the production cell. And some of the tolerances that were tied up in non-critical areas where that particular part of the component effectively would be in fresh air, it was ridiculous. Or the kind of angles or draft angles or compound angles that they'd put onto these components when it was totally unnecessary. It just kind of puts a big cost onto the production of these parts that is completely unnecessary. And I think and they couldn't be changed because they've been proven and passed by Rolls-Royce and the OEM company. So I think it kind of really highlights the fact that, design is absolutely massive. And I think that you need to know what you're designing. You need to know the application and you need to know how it's going to be made. And if you've never made it before, it's very hard to design it. Would you agree, James?
Yes, yeah, absolutely. Even inside Parker, there's been a lot of analysis done on that side of things, and there's initiatives in place now to address that. Parker, as a corporation, we're very in tune with that because obviously we're always looking to try and make improvements as much as possible, and find reduce costs or whatever, so we can pass those on to our customers and ultimately develop better quality products and deliver the best service we can for our customers. There's so many decisions that get made in the design stage of a part that that get left to the manufacturing side to address. It can cause a lot of problems later down the line. So trying to keep things the simplest way is always the best way, I've found. There's no need to go into too much detail about things when it's not necessary. And like you said, it's very much about understanding the application. Do you really need it?
Yeah, no, absolutely spot on. Lloyd, you've got something to say about this?
Yeah, I think much to James's point, I think holding unnecessary tolerances just for the sake of it in a lot of drawings, as much as it'll be difficult operationally, but you've got to think of the added cost for you to be able to machine it, and or the added potential scrap value if you can't achieve it on any of these products. You know what I mean? So I think it's very important for most businesses to consider cross-functional teams that are of paramount importance. But from the absolute onset of the new product introduction, most businesses do it almost like a marathon race. You'll have your pre-production engineers design it, we'll pass it to some production engineers, will program it, then operations are going to figure it out. But you really need all those guys around the table at the onset of any new project, because you could be trying to achieve something that's just going to incur you tons and tons of cost. And I think if you can bottom that out, you can pay yourself back later on when you talk about investment in machines and stuff like that. You could probably either lower spec your machine or something like that, or things will pay back quicker, rather than having told micron tolerances on stuff because a design engineer was not questioning on what he was doing.
Yeah, no, it's simplification, isn't it, Lloyd, to a certain degree, and kind of starting it from the component, not the machine, doing it the other way around. Now, Nick, you've got something to say on this.
Yeah, I mean, the thing is, with all new products, they start with the design engineer. That's the thing. And he designs everything, how he actually wants it to look, how he wants the tolerances to be, with no real thought for a production engineer or a manufacturing engineer who's actually got to make the part. That's the issue. So as Lloyd said, really you need everybody around the table to start with to get the part, not just with microns all over it, but actually working the most efficient way it can do, but actually manufactured in the most efficient way as well. And that comes down to what we started talking about, is the price per piece. You don't want this thing to be over-engineered. You said, it's got to be as simple as it needs to be without complicating any particular part or dimension on it.
Yeah, I think that boils down to communication, and I think that from my experience on the shop floor, it was definitely lacking from the operators on the shop floor to management to upper management, and I think that having that communication from the ground up all the way through the organisation is absolute. It's key, absolute key. Now, Nick, just sticking with you for 1 minute, work holding, it plays a big part when trying to hold, irregular shaped parts, castings, for example, and it must give you some big obstacles when you're trying to, give someone a solution. And again, surely this boils down to the design. People could potentially design a part with excess material on there or holding features, so you could do it in a more productive manner. What's the worst example that you've seen of a over-engineered part?
Oh gosh, there's quite a few, to be honest. The worst problem really is tolerances that are put onto parts that just don't need to be there, really, and relational tolerances that have then got to be machined into a part where you're actually holding on a part that's actually got to be machined within a few microns on the other side. So you're now transferring parts from spindles that have got to be held accurately. The amount of different shapes, we get hold on spheres and all sorts of things now, because the amount of things that are manufactured now aren't just car parts. They can range from medical parts, which you've got complex spheres and shapes on them, right the way through to aerospace parts and defense parts. But it still comes down to making things as simple as possible. Nobody actually usually thinks about work holding until somebody's got a part in their hand and they want to make it, and then it's almost too late. So one of the best things we do is actually talk to machine manufacturers with the customer, with tooling people, work holding people, and get round the table when people are trying to make a part and come up with the best solution for everybody. So at the end of the day, the customer gets a part that's made in the most efficient way possible, and it's all done with the right machine, the right work holding, the right tooling, and done in the correct way the customer wants. So it's important everybody as engineers within a company and also the different branches that are helping out to actually all come together and talk together.
Yeah, well, Nick, that leads me on to my next point absolutely perfectly, Nick. We were at Parker Hannifin, Sheffield last week, and Llyod, this is a perfect opportunity to tell the listeners about the latest investment in the automated cell. Now, this was a real collaborative project. So many different suppliers working on this project. Can you kind of tell our audience how it came about, really, and about what it entails?
So the product we manufacture are cryogenic valves. Again, any weird and wonderful size you can imagine. So we do a huge mix of variety in, like I say, product shape, sizes. But from a more specific machining perspective, it's really short batch work. So we're incurring so many sets on a regular basis. Typically we might be setting for half an hour on some of our older machines to run a 10-minute job. So, it's not productive from a financial perspective. So we really wanted to make an investment that we could really take a lot of that lost time out. And we really went to town speccing it from a perspective of what we wanted it to do. We wanted the flexibility of a robot to be able to load and unload this thing. We wanted bar feeding capability, which we'd not had or utilised much before. But then, really importantly, there was a strong focus on the reduction in like changeovers and setups, and that really made us focus in quite significantly on work holding and what we could do there. So the lathe we've gone with is a DMG Mori NLX 2000. So with a twin spindle, which is something we'd not utilised before having a twin spindle. We've got a hydrofeed bar feeder on the back, an ABB flex loader robot. But then most importantly, again, looking to Nick's company with the work holding, really going from 30 minutes to, in some cases, for a collet change, 30 seconds, is been such a game changer in our ability to service our customers in terms of lead time. but also from a cost perspective. The one thing I always say within the business is cutting and transforming product is what the customer is paying you to do. They are not paying you to set up or change your machine. So really, that's where Hainbuch fit the mold perfectly with that. Is that, if I'm going from one bar size to another, I don't have to incur any undue lost time. So all in all, that was about $500,000 for that entire package. But in initial instance, it sounds like an awful lot of money for any company to invest. But when you look at, when you're talking about 80% setup reductions on some of your key product families, this is going to pay back this business within a 2-year period. If somebody told you could give me a lot of money today, but in 2 years I'll pay you back, and then 2 years after that you'll double your money, it's probably an investment you're willing to make. So, like you say, it's been a very collaborative effort, but it's been from the outset, I think, a testament to the collaboration with businesses and actually fitting the original spec of what we wanted from it.
Yeah, I think that means fantastic points there, Lloyd. And I think that a good analogy there in regards to an investment, it's basically, once it's paid for itself, it's just continuously making money for free then, isn't it? So it's investment is key. And before I move on to the setup reductions, I mean, obviously, when you're doing low volume work, setup reductions is massive. But you wouldn't necessarily, or most engineers wouldn't necessarily assume that automation lends itself to high mix, low volume. What would you say about that, James?
It's a big sort of fear, I think. The key thing is that automation has come such a long way in the last few years. You can do almost anything with automation now. When we first started looking into it, we did start. We got the impression from people that we were speaking to that it might not be worthwhile because it is such high mix, low volume. Really, it's for when you're making thousands of the same part over and over again. But we persevered with it, and we found the system with ABB. And I think that the key thing with that sort of system is the vision system that we settled on. The ease of programming and setting up for that, and its ability to recognise the complexity of parts and shapes. It really, really helped us with that. And again, just don't close your mind to it. There's so much technology out there. There's something for everybody. And like we stuck with it, and we found, what I would think is the perfect solution for us.
I mean, it is a fantastic solution, and you don't often see two forms of automation on one cell, if you like. So you've got the bar feeder for bar, but you've also got the ABB for billets or casting components. So you've got ultimate flexibility there, and obviously it creates the unmanned running as well. So you can actually, run overnight 24/7, work dependent. Now, Nick, you've just had a fantastic testimonial there in regards to the work holding solutions that you've provided, and the kind of setup savings that's helped with. Can you explain what products you've got on the NLX 2000, Nick?
Yeah, sure. We've got two collet chucks, one at either end, which are our sort of top plus collet chucks, which have 65mm bar capacity. These chucks give you about 30 to 40% more clamping pressure than a normal 3-jaw chuck. And also far more clamping pressure than our normal system. But the secret of it is that you can change a collet over in literally seconds. And if you want to go, you can go as far with the automation side as you like. Once you've integrated a robot, which is the bit everybody's scared of, you can actually change over the collets with the robot and all sorts of things like that. So it makes changeover of parts, certainly with the work holding, very, very quick. So you can reduce your batch sizes and hence the price per piece as well. Then we needed a larger capacity as well. So they wanted to put a 3-jaw chuck back on when needed with some parts. Well, changing over 3-jaw chucks to collet chucks is not something everybody likes to do at all. It's time consuming. It's not particularly accurate. But our new 3-jaw module allows companies like Parker to change over from a collet chuck to a 3-jaw chuck in literally a couple of minutes and still maintain accuracy and high clamping pressure. So the secret of it all is to actually still maintain accuracy within the work holding and hence the part, maintain the accuracy, be able to change over quickly and still have a very high clamping pressure if needed. So you maintain the rigidity and hence the surface finish and the accuracy. So all that works together to actually make a part that comes out as really nice as some of those Parker parts do.
And effectively, you're keeping that spindle turning, aren't you? You know, you're making a big investment into to kind of that kind of project, Lloyd. And the last thing you want is, you know, half an hour setups, an hour setups, and that machine tool being down, not being fully utilised and used. So this kind of brings us back to, you know, how important is it in the UK for people to invest in the latest technology to reduce cost per part? Lloyd, I know that, you know, from the beginning of the podcast, you've looked into this a lot from a business perspective. How important is it? And I know that we're in a privileged position being able to visit a lot of shops where they've had the luxury to invest, but not just for big companies like yourselves, but for smaller companies too.
Yeah, I think you know, we've definitely seen in the last 10 years that there's been an ever increased focus on obviously profitability for businesses, and what's happened by extension to that is people have been looking more towards low cost countries. And I think, you know, as a UK manufacturing base, we're only starting to get as to grips with, you know, making investment on automation and things like that, because that does make us much more price competitive. But then, you know, the USP we have versus a lot of international competitors is the fact that our product quality is of such a higher standard, you know, and we're able to bring more work back in. So, you know, just within our business, as a case point, we've been able to insource in the last year about 7,000 hours per annum of machining work that was previously done by overseas subcontractors. You know what I mean? And that is a proper game changer for UK manufacturing. But, you know, Sheffield used to be one of the biggest manufacturing hubs in the north of England, and we can still be that. But it's going to take us to make investments and try and do some proactive work to make that happen. And, you know, like you said earlier about lights out and unmanned running, that's really how we do it, because in theory, we're not paying for the lights to be on in the factory. As an analogy, you know, if it is truly lights out, the facility is already paid for by 5 o'clock when we go home, let's say on the existing work. So everything I do thereafter is free work. So, you know, it's a massive game changer for us to be able to do things locally, cheaper, but of a much higher quality. And, you know, interestingly,
no, absolutely. I mean, it's key. It's absolutely key. And what part does education play into this? I mean, you know, there's still big barriers to entry for automation and work holdings overlooked. You know, some people just look at a collet chuck as a collet chuck or a vice as a vice. You know, what part does education play in this? Nick, I'm going to start with you.
Well, education, obviously, that's what I said earlier about apprenticeships, really. I mean, I think probably all of us did an apprenticeship, and actually it gives you a grounding, an overall grounding into the different facets of engineering and what's possible, what's not possible. But it's still a continual learning process all the time. You've got to keep your eyes open and be willing to learn. And as somebody said earlier, that technology is moving on so quickly. When I left school now, I couldn't imagine half the things that are happening now. And even 5 years ago, things have come on. Robots were looked on as something really quite unusual. Now we're getting them commonplace now, integrated in machines, plug and play robots, everything. The vision system that there is unbelievable, to be honest, that you can just place a part on a belt and the robot recognizes where it is, what's happening with it, and actually just the robot then picks it up and loads it into a collet automatically. Unbelievable. But you have to be willing to learn all the time as an engineer, which it makes it such an exciting job to do.
I couldn't agree with you more, and I think perception needs to change to kind of bring in like the best young talent into this industry, and I think that is also key. James, you're an apprentice yourself.
Yeah.
What do you think about this subject?
Just going back to what you said, education is the key to everything, but also equally just raising the awareness. I mean, just going back to the beginning of the conversation, I had no plans to become an engineer when I was a youngster. I was, dead set on trying to become a pilot in the RAF or a musician, professional musician. And then suddenly I just changed my mind and thought, right, I need to get out there and start earning some money. And then an opportunity, I was made aware of, and I took an interview for the apprenticeship and I got it. And within a week, I was like, actually, this is all right. And I thought I could be good at this and get into it. And I had no idea of the career opportunities that are available. So, like I say, raising the awareness of this kind of work, the rewards. It's very, very satisfying career. And like Nick said earlier, if you get into it and you stick with it, it's a job for life. And as we say in engineering, every day is a school day. We're always learning. It's so important. To be honest, personally, I think that this country, Llyod was speaking about trying to bring manufacturing back into the country, and I wholeheartedly agree with that. It needs investment, but we also need to foster and grow the talent. We've got such a high level of skill in this country. We need to invest, and we're banging our heads against a brick wall sometimes. If we've got the skills, just give us the kit, we can do it. And I think, culturally as well, I think there needs to be more champions, more heroes of this industry, just to bring that awareness to the young people of today. Get people excited about engineering, because there's so many people. When you're out in the world and you're talking about it, it's such a vast subject. You tell someone you work in engineering, they don't know what you're talking about. So it needs to be out there a little bit more, and it's one of the good things about MTDCNC. The young people now, everything's done on social media. There's they're living their lives on YouTube and whatnot, and there's already a fantastic presence there, but I think we just need to take it into schools a bit more. When I was about to start my apprenticeship, my granddad was a blacksmith. I went to help him out in his workshop for a week before, and I had a fantastic time. And he said, "Didn't the school take you around the local companies and show you what's there?" And we're like, "No, it wasn't like that." And there needs to be more focus on it. I think a lot of the education system now is quite academic. I think all people learn in different ways, and some people are naturally gifted at certain things, and they may not come to realise that while they're at school. And they're just giving people those opportunities to shine in the area that they're going to shine in. It could only be good for engineering. There'll be loads of kids in school now that would make perfect engineers, but they just don't know it.
Absolutely right, Dan.
Yeah, great. No, James, that's absolutely really, really, really great point. Like I mentioned at the very beginning of the podcast, like my children love trains, cars, stuff like that at the minute, and it seems like they go to school and it gets taken away from them. And like you say, they could be like engineering found you, James. You didn't find engineering. So how do they need, it needs to be focused on a lot more. And I mean, sometimes I don't want to mention any names, but when you watch the news and you see engineering companies on the news, it tends to be old oily shops. The perception of engineering in the UK certainly needs to be changed to make it a sexy industry to be involved in. I mean, you look at Oxfordshire, the Formula One industry. We need to be seeing companies like that more on the news. It's at the forefront of all technologies, and everything's made from engineering. And I think that, definitely things like this will help. But there's certainly so much more that needs to be done if we want to kind of get the best talent into the industry. Unfortunately, we're running out of time, so we could have another podcast completely on this. But before I go, Llyod, have you experienced any trouble getting young talent into your business, and if so, why is that?
You know what? Interesting point this, because one thing we've noticed, a lot of let's say demographics within the recruitment pool for engineers, it's aging somewhat, and the amount of apprentices is more and more difficult to find decent talent, let's say. So, it's something we're having to diversify as approach. And I think much to James's point, it's about whether we, when we promote, the champions in our field and stuff like that. But also, I think we're seeing a bit of a movement away from some of the younger people we are getting. They're wanting to get through the door, but then immediately become like programmers and, engineering managers. There's less appetite, let's say, to become to become experts in the field. And I don't know, I think it's more of a cultural thing maybe in the UK, that it's the immediacy of life. If we want information, it's on our phones. If we want a meal, it's a microwave ding away. You know what I mean? So I think it's about, as a society, potentially recapturing a little bit of that aspiration for, being able to make something with your hands, putting in the hard work and getting a decent product out at the end. And I think that's just going to be through education, showing that these things are available. They're not the easiest industries in the world and jobs to do, but, the level of gratification you get is astounding. So, that's something we are seeing and we're really trying to mitigate at the moment.
Really good point, Llyod. And again, thanks so much for all your time today. Nick, any last points from you, Nick, before we have to wrap this up?
No, not really. I think Eddie said some good things, to be honest there. What Llyod was saying about apprentices is absolutely true. Young kids, we need to manage expectations. You can't just come into a company and be a manager on £100,000 a year in 2 minutes. None of us have got where we've got to in 2 seconds. It takes time. But we have to enthuse kids, certainly, and get them to love engineering, really. And that's up to us to do it, really, and to prove to them that it isn't a dirty, grubby job. It's a very intelligent job, and it takes a long time to be an expert in it. But you have to work very hard.
Yeah, I couldn't. Again, I think it's been brilliant, and I think we could do another podcast on this. And I would take you up on that, guys, if you wanted to join me again. I think that it's our responsibilities in a way to kind of take it upon ourselves to give something back and to try and attract the next generation of engineers, because if we don't, who will? And it's like the passionate engineers like ourselves that need to do something about it. Well, thank you for listening to the MTD podcast. If you've got any comments about this podcast, please get in touch. Until next week, the MTD podcast.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on MTDCNC.com.